Have you ever wondered what it would be like to fall into a black hole? Black holes, those enigmatic celestial bodies that have captured our collective curiosity, are far more than just points of extreme gravitational pull. They are paradoxical entities, where the laws of physics as we know them seem to crumble. Imagine standing on the precipice of a black hole, the distortion of the sky growing greater and greater as you approach it. The darkness begins to consume a large portion of your forward view. It's as if you're staring into the abyss and the abyss is staring back. This is not the realm of the ordinary, this is the realm of the extraordinary, the realm of black holes. Now imagine reaching a point where half of your field of view is filled with darkness. You have arrived at an intriguing point in space known as the photon sphere. The photon sphere is not just any point in space. It's like a magical ring where light, or photons, are caught in an eternal waltz around the black hole, much like our Earth orbits the Sun. But the photon sphere holds another fascinating phenomenon. If you were to pause your journey and look to the side, you could theoretically see the back of your own head. The light reflecting off the back of your head would travel around the black hole and find its way back to your eyes. It's a visual echo, a mirror in the void. Yet black holes do not only distort space, they also distort time. An observer watching you approach the black hole wouldn't see you quickly disappearing into the darkness. Instead, your approach would seem to slow down, as if time itself was stretching out. So we have reached the photon sphere, a realm of unimaginable distortion. But the journey has just begun. This is the unseen universe, a place where the extraordinary is ordinary and where the rules of reality are rewritten. It's a place of endless possibilities and countless mysteries waiting to be unraveled. Now, we approach the point of no return, the event horizon. This is the boundary around a black hole beyond which nothing, not even light, can escape. It's a place of immense gravitational pull, where the very fabric of space and time is warped beyond comprehension. In the realm of a black hole, things get a bit weird. If you were to approach the event horizon, you'd notice a strange phenomenon. To an observer watching from a safe distance, your descent would appear to slow. You'd seem to hover at the edge, gradually fading away as the light reflecting off of you becomes increasingly redshifted. A phenomenon caused by the extreme gravity stretching the wavelengths of light. This is what's known as time dilation. It's a mind-bending consequence of Einstein's theory of relativity, which tells us that time and space are not as constant as everyday life would suggest. Under extreme gravity, time seems to slow down. But what about your own perspective? Well, as you cross the event horizon, you wouldn't feel a sudden jolt or see a flashing sign saying point of no return. To you, it would feel like any other moment in space. This is because the laws of physics, as we understand them, still apply within the event horizon. The black hole doesn't simply erase them. Instead, it stretches them to their absolute limit. Gravity at the event horizon is tremendous, but if you're falling into a supermassive black hole, you might not feel much of a difference at first. However, as you move further in, the force of gravity becomes increasingly stronger. This is where your journey towards the singularity, the heart of the black hole, truly begins. The event horizon is a fascinating and terrifying boundary. It's the last stop on the cosmic highway before we enter the realm of the unknown. It is a place where our understanding of the universe is challenged, where the familiar rules of space and time are distorted beyond recognition. To the rest of the universe, you disappear at the event horizon. But in your reality, the journey continues. Beyond the event horizon, we head towards the mysterious singularity. As we continue our journey, the universe behind us condenses into a smaller and smaller point. As if we're looking through the wrong end of a telescope, the vast cosmos we once knew becomes a minute speck in the distance. It's a humbling reminder of our place in the grand scheme of things. Our attention, however, is drawn forward to the singularity. This is where the laws of physics as we know them start to break down. This is the heart of the black hole, where space and time are twisted and stretched to the extreme. As we near the singularity, we encounter a phenomenon known as spaghettification. The tidal forces here are so strong that they stretch and distort everything that comes near. Imagine being pulled like taffy, your body elongating into a thin, noodle-like strand. This is what happens as you approach the singularity. It's a one-way trip with no chance of return. But what happens when we reach the singularity? This is where things get even more mysterious. The truth is, we simply don't know. The laws of physics can't predict what happens in such extreme conditions. But that doesn't stop us from speculating. One theory suggests that we might disappear, violating every law of physics we hold dear. Another proposes that we might reappear elsewhere in the universe, having traveled through a wormhole. There's even a theory that suggests black holes could be linked to white holes, theoretical objects that spew out matter instead of consuming it. Could a black hole lead us to a white hole and potentially another universe? These are questions that continue to baffle and intrigue scientists. As we push the boundaries of our understanding, we delve deeper into the unknown, embracing the mystery and wonder of the cosmos. As we approach the singularity, we confront the unknown. Could we disappear, reappear elsewhere, or even enter another universe? Our journey into a black hole has been an extraordinary one. From the distortion of the sky to the magical photon sphere, where we could theoretically see the back of our own heads, we've plunged into the depths of the unknown. We've crossed the event horizon, the point of no return, and stepped into a realm where even time is distorted. We've traveled towards the singularity, where our view of the universe condensed into a mere point, and faced the incredible phenomenon of spaghettification. We've grappled with the mystery of what happens when we reach the singularity, where our atoms and molecules might disappear, reappear elsewhere, or even venture into another universe. But our journey doesn't end here. It's just the beginning. The black hole could be linked to a white hole through a wormhole, a theoretical shortcut through the space-time continuum. What are white holes and wormholes? Well, that's a tale for our next episode. Until our next cosmic journey, stay curious, stay thoughtful, and never stop asking questions. As we conclude this episode, let's contemplate the theory of wormholes. A wormhole is theorized as a shortcut or a passage through the fabric of space-time. Imagine folding a piece of paper and making a hole through both ends. That's a basic illustration of a wormhole. It potentially connects two remote points in our universe, two distinct universes, or two different moments in time. Although these theories are yet to be proven and need further scientific exploration and evidence, they offer a captivating peek into the potential nature of our incredibly intricate and captivating universe. This is Earth and Beyond. Although we're concluding for today, our exploration of the cosmos is far from over.